Let's graph the linear inequality in the plane. This says y is less than or equal to negative 1/3 times x plus 1. The first thing we want to do is remember to graph the associated line with this inequality. It is in y equals mx plus b form, where m is the slope. So it says negative 1/3. That could be interpreted as if you have an ordered pair on a line, from that ordered pair you're going to go down 1 and then right 3. Now we also know the y-intercept, and if you translate the y-intercept to an ordered pair, you'd know that this translates to 0, 1. So the first thing we're going to do is draw your set of axes. Do the best you can. You want to first plot the y-intercept. And the y-intercept is 0, 1. The slope says go down 1 and then right 3. I'm going to put 3 marks this way. And we get another dot here. And if you have a ruler, take advantage of a straight edge or a ruler and plot a straight line. And so you have a straight line there that goes through those two ordered pairs. And it is a solid line, and the way you know that, it says less than or equal to. The equal means you could actually shade this line. Now, we want to shade the true side of an inequality. So we're going to take the original inequality and choose a test point that is not on the line. Let's take the original inequality. And choose a test point that's not on the line. So why don't we pick on the origin here? Why don't we test the origin and see if we are able to shade it. So 0 is less than or equal to negative 1/3 times 0 plus 1. We want to know if this statement is true or false. 0 is less than or equal to 1. This is true. And what that means is 0, 0 is lying on the true side. 0, 0 is right here. We are actually going to shade 0, 0. In fact, you're not only going to shade 0, 0, you're going to shade negative 99, 0 as well, because it lies on the same side of the line that is going to represent a true inequality. So you only need to test 0, 0. You only need 1. If you test, you could easily test what? 0, negative 3. If you test 0, negative 3, it's going to work as well. It's going to give you a true statement. So we always shade all the true statements. In this case, we shade the 0, 0 side. So let's shade. We can also shade this line because it's equal to. So I could paint this line as well and shade that line. And now you shaded the entire solution set. So the answer to this problem is actually a graph. When you do this kind of graph or this kind of shading, you want to indicate your test point. So make sure you indicate your test point. Of course, you know how to graph a line from previous algebra courses. Let's do another linear inequality. Once again, you want to write down the associated line. This one has ax plus by is equal to c. The associated line that you want to graph is negative x plus 4y is equal to 8. So we're going to graph this straight line. Now this time it's a dotted line. How do you know it's a dotted line? You don't have an equal symbol underneath that greater symbol. It's strictly greater. Over here, this was what? This one here was solid line. This time we have a dotted line because of that symbol there. Easily graphed with the intercept method here. So if you use the intercept method, I can go ahead and give you the intercept method as ordered pairs as well. So when y is 0, we get x to be the opposite of 8. So 1, 2, 3, 4, 5, 6, 7, 8, opposite of 8. Plot a point here. When x is 0, we get y to be 2. When x is 0, we get y to be 2. And we could plot a point at 0, 2. And of course, if you have a straight edge, take advantage of it and plot a straight line. So you not only draw a straight line, you're going to draw a dotted line with the arrows at the end. Make sure you draw the arrows because you do need to match the domain and range of that linear function. Once again, we're going to test the original inequality, and then we're going to pick a test point to make sure we shade the correct side. We either are going to shade above the dotted line or below the dotted line. A convenient test point would be 0, 0. So why don't we test 0, 0, negative 0, plus 4 times 0 is greater than 8. True or false? Well, that's bogus. 0 is definitely not greater than 8. So this time, we do not shade the false side. In other words, we are going to shade the true side is actually above the line. We cannot shade the 0, 0 side. Now keep in mind you are just going to shade above the line. This time, because the line is dotted, we don't shade the line at all. In other words, that y-intercept is not a solution. And you're done. Once again, make sure you indicate the test point you are going to use. It's nice to graph and label all your ordered pairs as well. If you want to make it clear, you can go back and label your ordered pairs like 0, 1, and then what, 3, 0. Over here, this was negative 8, 0, and then this one was 0, 2. Always nice to label things very, very neat.